वेलकम स्टूडेंट। क्लास 9 cbse नंबर सिस्टम को लेकर हम डिस्कस कर रहे थे। आज हम क्या सीखेंगे कि हाउ टू कन्वर्ट ए रैशनल नंबर टू ए डेसिमल। ओके, बिफोर स्टार्ट टुडेज क्लास I want to say something that you must have a clear concept about rational number. Okay, so what is rational number? We already discussed it in previous classes, but I want to repeat it again. So, rational number are those numbers which are basically in the form of numerator by denominator, where denominator must be not equals to 0 and both are integer. Okay, any rational number can be converted into a decimal number by actual division method, and we arise two cases. When you convert it into decimal, we arise two cases. One is after a finite number of digits, the process is terminated. So we can say it a terminating decimal. But after a finite number of digits, if the process continues endlessly, then we can say it non-terminating. And one thing, a rational number when is non-terminating, you can say it one digit or a block of digit is repeated themselves, so we can say it non-terminating repeating decimal or non-terminating reoccurring decimal or recurring decimal. Okay now, so let's see some example. Here I can take some example for my mind. You can take something else also if you want. Okay, so our first example is 32 divided by 100. So let's divide it. You can see the dividend is smaller than the divisor, so we place a decimal here and a 0 here. Now dividend is greater than the divisor, so we may proceed. 100 3s are 300. Remainder comes 20. Again we place a 0 here. 100 2s are 200, and you can see that the remainder is 0. Means after finite number of stage, the process is terminated. Okay, let's see next example. 8 by 125. So let's divide 8 by 125. Again you can see that the dividend is smaller than the divisor, so we place a decimal here and a 0 here. But again dividend is smaller than the divisor, so we place a 0 here and a 0 here. 125 4s are 500. 5 j 625. 6 j 750. 7s are 875. So 6 times 8 gives 750. Remainder is 50. So now 50 is smaller than the 125. So we place a 0 here. 4 times 500. Again you can see it, the process is terminated after a finite number of stage. Let's move on to the next example. That is 1 by 3. So let's divide 1 by 3. Again you can see that the dividend is smaller than the divisor, so we place a decimal here and a 0 here. 3s are 9. 3s are 9. 3 3s are 9. Remainder is 1. Again we place a 0 here. 3 3s are 9. Remainder is 1. Again we place a 0 here. 3 3s are 9. Again our remainder comes 1. If you notice, then you can see it that every time our remainder is same. Okay, and it is 1. So the digit in the quotient 3 is also repeated and it continues endlessly. So we can write it as 1 by 3 is equal to 0.3 dot 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 is equal to 2 times 3 bar. Okay. So when we convert a rational number into a decimal, we can see that after a finite number of stage, either the digit is terminated, either the process is terminated. So those are terminating decimal. And here we can see that the process continues endlessly. So this is non-terminating, and a block is repeated itself. So this is non-terminating repeating decimal. Okay. As you can see, by actual division method, we can easily say that a rational number is terminating or non-terminating. But without actual division method, can we say that that a rational number is terminating or non-terminating? Let's see. A rational number is basically in the form of numerator by denominator, where denominator not equals to 0 and both are integer. We will just factor the denominator by the prime factorization method. Okay, by the prime factorization method. If the denominator of a rational number contains 2 or its power, or 5 or its power, or 2 and 5 both, then we can say that the rational number must be a terminating decimal. We can say that this is a terminating decimal. But if the denominator of a rational number contains any other prime factor which is other than 2 and 5, so we can say that this rational number is a non-terminating decimal. Let's see it by note. Let's see two notes. Note 1 states that if the prime factors of the denominator of a fraction are 2 or 5 or 2 and 5 both, then the fraction is terminating decimal. And note 2 states that if the prime factors of the denominator of a fraction are other than 2 or 5, then the fraction is non-terminating decimal. Let's see some example. This is 13 by 80 and this is 11 by 35. We don't have to do anything. We just have to write the corresponding note. After factor the denominator, we just have to write the corresponding note. Let's say 30 by 80. First of all, you have to factor the denominator by prime factorization method. So 2 42 ja 80, 22 ja 40, 2 10 ja 20, to 5. So we can write 80 as 4 times into 5, 2 to the power 4 into 5. Okay. So we can replace 80 by 2 to the power 4 into 5. Now, as we know, you just have to write the corresponding note. Okay. As we know, if the prime factors of the denominator of a fraction are 2 and 5, then the fraction is terminating decimal. Okay, here our denominator is 80, so we can write here 80 has prime factors 2 and 5. So 13 by 80 is a terminating decimal. Okay. Next example is 11 by 35. So first of all, we have to factor the denominator by prime factorization method. 35 is equal to 5 into 7. So we replace 35 by 5 into 7. We just have to write the corresponding note. If the prime factors of the denominator of a fraction contain a factor which is other than 2 or 5, then the fraction is non-terminating. We just have to write the corresponding note. Now here 35 has a prime factor 7, which is different from 2 and 5. So the fraction is a non-terminating decimal. Okay, note it down. We will meet again in next class.